Hi folks, this is Jigar Savla here, doing another video on verification, especially UVM based verification, explaining to you what happens behind the scenes. Today we'll be discussing the proxy pattern. Now proxy is an object-oriented programming design pattern widely used in the industry, and we'll see how it's being used in UVM. And before that, we need to understand what proxy is. And for that, we'll actually be doing a live coding of a proxy design pattern in SystemVerilog so that you feel more familiar with it. You could use it in different places within your verification test bench. So we first look at how the inheritance structure is looking like for a proxy pattern. So here in this diagram, you'll see on the below my video, you will see that there is an object class to the left here. Then below that there is object D1, which is extending object. Object D2 extends object D1. It has a print function. The print function is just saying I'm an object D1, and I'm an object D2. Then we have a parameterized typecasted class called as object proxy. It'll have one function, create object, and it'll return an object of the type T. And this class is going to be a pure virtual class. Pure virtual classes mean that we cannot instantiate an object of object proxy. Object proxy is extended by object wrapper, which is also once again parameterized, and it finally implements the function create object, and it will also return the value in the form of the type T, an object of type T. As a user is where the third column lies. And as a user who likes to override objects, what would they do? They would first set an associative array, let's just say, called as proxy, which takes in keys of string parameter and the value of a object wrapper. Then the user chooses to override the object with an object D2. Here, to make it more flexible, what we are going to do is we are going to have the proxy associative array have the key of string and the value as object proxy. So I hope you can see my screen. Let's start coding. First, let's try what we're doing. Proxy design pattern. All right. First, we start off with is a virtual class of type object. We are going to follow the diagram below my video so that it's easier to follow. You can also implement it soon. We will end class object. Then inside it, we'll declare a pure virtual function called as print. We'll also have a return type of void. Then let's extend this. This one we don't want virtual. We want just as a class. Object D1 extends object end class object D1, and here we'll implement the function virtual function void print and function print display and object d1. Now the final class inheritance structure within the object tree. Virtual function void print and function print and object d2 print. Then in the module myTest is where we finally do the fun stuff. In terms of instantiating, though first we need to wrap up what we did, what we need to do for the object wrapper and the object proxy. So let's get to that. We'll declare this as a virtual. So that we can never have an object of type object proxy and class object proxy. Inside, we mentioned that we have just one function of the type create object. So here we can use the pure keyword, pure virtual function, and yes, we said we'd also parameterize it. So let's do that. Type T. For now, just on default instantiating it as int. Pure virtual function. And return type of T. Create object. Now we'll extend it, and this class is going to have more to do than all the above classes combined. Class object wrapper type T extends object proxy. Yeah, the interesting thing about having a type parameter is that when you're extending a class which has a parameter, you don't need to mention it here. And class object wrapper. Okay. The first thing we need to do is have a create object there. So let's do that. Virtual function T create object and function create object, and internally we are going to create a new handle for this typecasted T. We'll just call it th. We'll new the th and we'll return th. Alright. Now in module myTest, what do we need? We need to show that given I think at this point it's a very good thing to mention that proxy by definition is a lightweight stand-in for the actual object. In this case, our actual object are amongst the object tree. So the object objd1 and objd2 those are the objects we want to create and want to use in our system, though we will have a lightweight stand-in for them in the lieu of object proxy or object wrapper. And why do we do that? Because some objects could be very heavy and you only want to create them when you need to. And secondly, by having the proxy class, you can also use some elements of the factory design pattern with regards to overriding the instantiation of the object. So if you had initially created initially created a proxy pattern for objd1 string as an objd1, you could later on override it to objd2, and any further invocations or newing of this objd1 proxy key would lead to an object being created of objd2. Might sound a bit confusing, so just stick along with me, and as we go through the code, things will become much simpler. So first thing, let's create handles, shall we? So objd1, we will create od1 inst, and we'll also create for od2 inst. And here let's do a type def of the object wrapper, and let's parameterize it to object d1, and we'll call this od1. Yeah, od1 right. Then let's have another one, object wrapper objd2, typo here, and od2. Another key thing, what does a proxy look like? In a simplistic fashion, we are just going to have an associative array in SystemVerilog equivalent to a hash map in any other language. It's a sparse array. All right, what are we going to have? We are going to have an object proxy type of an associative array called as proxy, with the key being a string. That's it. This is the actual proxy. And at this point, let's just test if there are no syntactical errors. All right, I do see some. Let's see. Okay. Let's just have some default parameters here. Okay. Now let's remove the word drop from here. It's complaining about the return type of T. So now, if I were to swap this out with an object class, okay. So for now, actually, let's just remove this. Yeah. So object proxy is an empty class. Now let's new these OD1 inst and OD2 inst. OD1 inst. Okay. Now that we've newed it, let's type new the object standards. Assign override 1, and here we'll assign the proxy for objd1 to od1 inst, which becomes now a stand-in, so that anytime we call proxy and we new it, we should see the return value. We can test it out. So let's do here. By newing, creating, in this case, by creating. And printing. So we have the base class for object ob inst. Okay. Or obh. Let's just make it a handle. obh is proxy jd1, and remember we used to always do create object, so we have to do a create object here, and then we do obh dot print, and let's guess what happens. All right. Oh. We've assigned od1 inst, and that's fine. Here the thing it's complaining about is the create object is not a class item. Because we deleted it from here. This was leading to compiler errors. Let's have it as a pure virtual function instead of T or the type object. Right? And this is essentially our UVM object. Alright, so what do we see here? The test completes. It prints out and it's in objd1. I'll just copy this, paste it here. Right? It's in objd1. Now I can override the proxy to say override objd2, and we will this time override it with od2 inst. Although we want to override 1, not d2. Yeah, let's do this, and let's also assign object d2. Okay, so what we have is objd1. When you create it, you should see od1 is being created, and this testing for objd1. Let's test it out for objd2 as well. And this should print out objd2. Then we've overwritten and we'll test it later. Alright, so we correctly see objd1 and objd2 being printed out via these two print commands. That you can see that we are only using the object handles, and we are using proxy to create our objects. The objects have not yet been created till we do create object. Till now, what we just have is a proxy object, which is stored here, which is lightweight. Now, for proxy objd2, objd1, we've overridden it to od2 inst. So, if we were to call this code again, and then see what happens, would it print objd1 again? Let's see. Aha. So we see objd1 being printed and then objd2 being printed again. So d1 here, d2 here, and d2 here. So d1 here, d2 here, and d2 here. Why? Because we just overrode it. And you can have as many extensions of the object class as you want. To wrap up and think about how it applies to UVM, think about these objects here as UVM object. As you know, UVM object is the base class for all the objects, for all the instantiations which you are going to do as a UVM class. Sequence, driver, monitor, scoreboard, all of them are extended from UVM object. The object proxy and the object wrapper is what is being used as one component of it within the factory, and we'll go to the factory in our next post. So with this, Hopefully, it gets you a better understanding on what it means for a proxy design wrapper and how you can implement it yourself using just SystemVerilog so that you understand the basics and then you can extend it to thinking about how it is done in UVM. Thank you so much.